We are Irish Side of the Moon. Freedom of information, personal empowerment. The Irish Side of the Moon.
I still have a dream.
There are many sources of energy available.
Everything is energy. My God, do we need this or what? Free our mind.
Corporations have taken over the world.
Freedom of information, personal empowerment. The Irish Side of the Moon.
Let's imagine that you had bacteria that doubled in number every minute. So this means they're growing steadily. The doubling time is 1 minute. Let's suppose you put one of these bacteria in a bottle at 11 a.m. and then observe later that the bottle is full at 12 noon. So there's our ordinary case of steady growth in a finite environment of one bottle, and the growth has a doubling time of 1 minute. So there are 3 questions to ask. The first question is, at what time was the bottle half full? And the answer is 1 minute before 12, because they double in number every minute. And so the second question is, suppose you were an average bacterium in that bottle. At what time would you first realize that you were running out of space? And the third question is, suppose that at 2 minutes before 12, some of the bacteria realize that they're running out of space, so they launch a great search for new bottles. And they search offshore and on the outer continental shelf and the overthrust belt and in the Arctic, and they find 3 new bottles. Now that is a colossal discovery. That discovery is 3 times the amount of space they ever knew about before. They now have 4 bottles. Before the discovery, there was only 1. Now, surely this will give them a sustainable society, won't it? Well, just look at the score. At 1 minute, at 12 noon, 1 bottle is filled, and there are 3 to go. At 12:01, 2 bottles are filled, and there are 2 to go. And at 12:02, all 4 are filled, and that's the end of the line. Well, that's a little like a guy who jumps off the top of the Empire State Building, and for a second or two, he's having a wonderful time. This free fall, and it's just very exhilarating. And he passes someone on the window on the 83rd floor, and the guy leans out the window and says, hey, look out, there's a ground down below. But the falling guy says, oh, no, everything's fine. We can go on like this forever. And, of course, the ground is down there, and his person will ultimately find out about it.
Hello, you're very welcome once again to the Irish Side of the Moon. This is something like 124 shows. This is Michael Leddy at the microphone. The guest is Albert Bartlett, Professor Albert Bartlett, and the subject is population and the exponential function. Check us out, irishsideofthemoon.ie. You can find us on Facebook, you can find us on Twitter. I would heartily encourage you to find us on those locations, and I would also say that I myself, Michael Leddy, am on Facebook. It's a Facebook page dedicated to the behind-the-scenes research, etc., for the Irish Side of the Moon. Albert Bartlett, I'm going to read the first couple of paragraphs from a paper of his called The New Flat Earth Society to set the tone for the show ahead of us today. Okay, jump right into this. There was a time long ago when people thought that the Earth was flat, but now, for several centuries, people have believed that the Earth is round, like a sphere. But there are problems with the spherical Earth, and now a new paradigm is emerging, which seems to be a return to the wisdom of the ancients. A sphere is bounded, and hence it is finite, which implies that there are limits, and in particular that there are limits to growth of things that consume the earth and that live on it. Today, many people believe that the resources of the earth and the human intellect are so enormous that population growth can continue and that there is no danger that we will ever run out of anything. For instance, after a United Nations report predicted shortages of natural resources that would follow because of continued population growth, Jack Kemp, who was then Secretary of Housing and Urban Development in the cabinet of President George Bush, is reported to have said, "Nonsense. People are not a drain on the resources of the planet." These people believe that perpetual growth is desirable. Consequently, it must be possible, and so it can't possibly be a problem. At the same time, there are still a few remaining spherical Earth people who go around talking about limits, and in particular about the limits that are implied by the term carrying capacity. But limits are awkward because limits conflict with the concept of perpetual growth, so there is a growing move to do away with the concept of limits. Those are the words of Professor Albert Bartlett, our guest on The Irish Side of the Moon. And I'm on the line right now with Professor Albert Bartlett. Hello, how are you today?
I'm fine, thank you, Mike.
Thank you for making time to join us on The Irish Side of the Moon. I'm looking forward to talking with you about the ideas that you put forward in your papers. I think they're very important ideas and very vital that everybody does what they can to get the message out there. Before we talk about that, I always ask people a little bit about their background. Always like to know how people were in their younger years before they got started. Take me back in time for a minute. Before you got knee-deep in studies, what were the things that drew your interest? Were you always interested as a teenager, as a kid, in looking at population, looking at growth, looking at math? Was that always a part of what you were doing when you were young?
No, it was not part of what I was doing when I was young. No, when I was in high school, I started hitchhiking around the country. I had a year of college, and then I dropped out and worked on iron ore freighters on the Great Lakes. And we would go up and get 10,000 tons of iron ore and run down we'd get it up in the Superior, Wisconsin area, and then we'd steam down to Buffalo, New York, throw it in a blast furnace, and up and down. And I was just a dishwasher on the ship, and I used to sit sometimes and wonder, will we ever, as a nation, run out of this rich iron ore we're bringing down? And then I said to myself, Al, you're just a dishwasher. There are smart people in Washington. If there's any problem of running out, they will alert us in time so that we can stop using all this stuff. And I'm ashamed to admit how many years it was before I realized that my faith was misplaced and that we would just go on using it until it was essentially all gone. And now, of course, they're using a much lower grade of ore, and they have to process it up there. It's called taconite now, what they're using now. So then I was on that ship the day of Pearl Harbor, and then I thought, well, I better get back to school. So I transferred to Colgate University in upstate New York, and that's where I first took physics. From there, after graduating in 1944, I went down to I took a job sight unseen down in New Mexico, and I hitchhiked, drove trucks, and hopped freight trains to get down there, and showed up for work in Santa Fe as instructed. And it turned out this was the atomic bomb project, and so I was working on the A-bomb for a year before the end of the war. And then after the war, I got married and went to graduate school, and then took a job here at the University of Colorado in Boulder. And it was only here that I started thinking about the arithmetic of growth and the way people didn't understand the arithmetic and didn't understand the very large numbers you can get if you have modest rates of growth for modest periods of time. And so I started in 1969 to lecture on this, and out of this grew my interest in population, because population growth is the most serious of all the growth problems that we have. And it's the most serious problem that faces the world today.
All of your ideas come before you even get to talk about population, before you get to talk about growth. You have a very solid foundation. Your ideas come from math, figures, logic, and common sense. So that was your grounding. Once you began to study and once you began to write papers, you really are coming from a place of common sense and cold, hard logic.
Well, I hope so. I do my best, and if I get off the track, somebody's bound to correct me, so I'm very careful.
When you talk about math and in terms of the power it has over us, because it really does define everything that happens in the world. When you talk about sustainability, when you talk about the exponential equation, can you tell us a little bit about those aspects of math and how, when you say something like doubling the amount of grain on a chessboard, starting off in 1 square with 1 and then moving to 2 and then moving to 4, how you rapidly get very large numbers?
Well, the chessboard example is a good thing. The thing that we need to note is that steady growth, like 5% per year, gives you doubling of the growing quantity size in a fixed length of time that you can calculate by dividing the percent growth into the number 70. So if you have 5% growth per year, you divide the 5 into 70, and what you find is the doubling time is 14 years. So this means that a thing growing 5% per year will double in size every 14 years. Now what happens when you have a modest number of doublings? And here we go to the chessboard. And the legend has it that the game of chess was invented by a mathematician who worked for a king, and the king was very pleased, and he said, "I want to reward you." And the mathematician said, "My needs are modest. Please take my new chessboard, and on the first square, place 1 grain of wheat. On the next square, double the 1 to make 2. On the next square, double the 2 to make 4. Just keep doubling till you've doubled for all 64 squares. That will be an adequate payment." Well, we can guess that the king thought, "This foolish man. I was ready to give him a real reward, and all he asked for is just a few grains of wheat." Well, when you look at this, you find on the first square there's 1 grain, the next square 2, the next square 4, the next square 8, and then it goes up. By the 10th square there's a little over 1,000. By the 20th square there's a little over 1,000,000, and you just keep going until you get to all 64 squares. And what you find is that the number of grains is approximately, roughly, 400 times the worldwide harvest of wheat in the year 2000. So that number is probably more wheat than humans have harvested in the entire history of the earth. And you might say, "Well, how did you get such a big number?" And the answer is it was simple. We just started with 1 grain, but we let the number grow steadily till it had doubled just 63 times. So that's our example of the enormous numbers you get with just a modest number of doublings.
Okay, but let's take it out into the real world and look at the idea of growth, as in growth of the economy or growth of the population. Surely growth is good, because politicians have been telling me and you that all our lives. Growth is a good thing, and it's what every society, culture, country, what have you, should strive for. Growth equals prosperity. Yes?
Well, that's true. They all say this, but the growth is dependent on resources. Resources are finite. And right now you read about water shortages around the world. Some places are in very serious trouble. In the American Southwest, so much of it depends on water from the Colorado River. That river is oversubscribed, and we're having a period of low flows on the river right now, And so some of the reservoirs, such as Lake Mead behind Hoover Dam, are very low, and it's so low that Las Vegas, the city, which gets its water from Lake Mead, the water is about down to near the point of the level of the water intake for Las Vegas. So Las Vegas has had to spend a lot of money to try to tunnel underneath Lake Mead so that they can get the last drop of water out of Lake Mead as the thing dries up. So water is in a shortage, and so you can grow as long as you have infinite resources. But we don't have infinite resources. There are limits to growth. And this was pointed out very prominently in 1972 by a group of systems engineers at MIT who did a computer simulation of the global economy. And they published this in a book that they called Limits to Growth, 1972. And this showed that there would be a total breakdown of society sometime in the middle of this century. The breakdown brought on by shortage of resources, shortage of energy, air pollution, water pollution, and overpopulation. They all combined to bring down the society in the middle, in a very dramatic way, in the middle of this century. So this is the thing. We have to realize that growth, if a society has to have growth in order to be a healthy society, then that society is like a Ponzi scheme, and the Ponzi scheme always breaks down when the demand gets so big that it can't be satisfied because of the lack of resources.
And you get across that idea very well in one of your papers by coming up with the idea and the expression of the new flat Earth society.
Yeah.
The idea being that only on a flat Earth that is always expanding to infinity do we have infinite resources.
That's correct.
And yet, is it true to say that policymakers in the modern world, in our modern society, seem to make decisions as if we were on that flat Earth?
Yes, all the decisions we see made by people who are making decisions is that they seem to assume there will always be all the energy we want, all the water we want, all the food we want, that everything will be as it is today. Yet we have world population growing something like 1% per year. We have U.S. population growing by something like 1% per year. Now here in the U.S., that 1% per year, our population in the U.S. is a little over 300 million. Now let's make some comparisons. The first number I learned as a child for the population of the U.S. was 120 million. Now it's over 300 million. We fought World War II with a population of something like 150 million. Now the population is growing about 1% per year. So that means there are approximately 1% of 300 million, that's 3 million. So there are about 3 million extra people every year. Now let's just tie this into current news items. We hear so much in the political campaigns about creating jobs. Now if we have 3 million new people every year, let's make a guess that 1/2 of them have to be workers who earn wages, and the other half are children and dependents. So we've got to have 150 million. That's half of 300. We got to have one and a half.
Yeah, I know what you're saying. 1.5 million.
1.5 million new jobs every year, and that's about 150,000 new jobs every month. Well, the newspapers have told us in several times recently with the employment figures that say there were 50,000 new jobs created last month or something like that. And then they go on to say, but it takes 125,000 new jobs a month just to keep up with population growth. So this is a millstone around our neck. We can't create jobs fast enough just to give jobs to the increasing population that we have.
And yet it's something that isn't said. You have observed that scientists tend to be politically correct, tending not to say things that would be deemed offensive or unpopular. And this message could be deemed offensive and unpopular. Therefore, it's a message that is not being put out there.
You are correct. Scientists will not talk about overpopulation. They talk about global warming. The principal cause of global warming is overpopulation. And you cannot do anything significant. You can do little things about global warming, but in total, all the little things won't add up to doing very much in total unless you have a corresponding thing of stopping population growth. Because population growth overwhelms everything that you try to do. Now, this is a message of mathematics that was first communicated around the year 1798 by Thomas Malthus in England.
Yep.
And people have ridiculed him ever since. And in particular, economists who don't like Malthus, they say, oh, we've proven Malthus wrong. That's crazy. I have read Malthus 3 times. This guy understood the problems, and he stated them in terms that fitted the economy of the year 1798. And he didn't anticipate the big increase in agricultural production, food production. Well, what's the reason we have this increase in food production? Well, the main thing is petroleum. And petroleum is used on farms all over the world. And we are now approaching peak petroleum worldwide. And following peak petroleum, we will have peak agricultural production. And as petroleum production worldwide declines, we will have a decline in agricultural production. Well, we're already seeing predictions of food rioting within the next few years just because of the increased cost of food as food becomes less and less available. We've been here in the United States outsourcing a good deal of our food production. We take valuable agricultural land, put subdivisions and shopping centers on it, and then figure we can get food from other countries. So right now we're importing something like 20% of the food we consume.
That's a high number. And again, assuming that we are coming to the end of the oil age and that it has severe knock-on effects in other parts of society, such as food, then having such a high dependency on food that has to travel a vast distance is very, very it's negative connotations there, to say the least.
It's very frightening. It's threatening our way of life.
And these are not, as you say, some of these thoughts go back a couple of centuries. Some of these things go back 1971 or 72 limits to growth. And yet, there's incredible resistance to getting the message out there. Why does the mainstream, why does the government, why do the powers that be resist this message?
Because they listen to economists. And by and large, economists all think the world is infinite and that there's infinite substitutability. So you run out of whale oil and you find petroleum, and you always find substitutes. And, you know, I haven't heard of any substitute for water. I haven't heard of any substitute for petroleum. Petroleum is unique in the high amount of energy per pound that this liquid petroleum has. And there just isn't anything else like it that competes with it. And you know, all the shortcomings of electric cars is that you can't get enough batteries in a car to take it more than about 100 miles and without recharging the batteries.
And yet they still put forward the same message that we're not in any great trouble and that there are solutions to these impending problems.
Well, people like to believe that. And they say we've always found solutions to problems in the past. Well, that's a little like a guy who jumps off the top of the Empire State Building, and for a second or two, he's having a wonderful time. This free fall, and it's just very exhilarating. And he passes someone on the window on the 83rd floor, and the guy leans out the window and says, "Hey, look out, there's a ground down below." But the falling guy says, "Oh, no, everything's fine. We can go on like this forever." And, of course, the ground is down there, and his person will ultimately find out about it.
That's a sobering image and a very, very succinct way of getting the message across. We're building to our first break. Stay with me on the line. We're coming right back on the Irish Side of the Moon with Professor Albert Bartlett. And I'm on the line with Professor Albert Bartlett. We have been talking about the core elements of math and how they are the foundation of some very solid critical thinking analysis of the world we live in and ideas behind growth and population growth in particular. I wanted to look at, again, so many papers you've written covering this subject from different aspects, looking at the idea and the meaning of sustainability, the idea of being able to sustain a population, being able to sustain. Talk to me about that. Tell me what is required to sustain the picture that you are putting forward in the first part of our chat.
Well, sustainability has to mean for a period of time that's very long compared to a human lifetime. I mean, you don't want to talk about sustainability for the next 15 minutes or sustainability even for the next 15 years. You want to talk about sustainability as meaning our children, our grandchildren, our great-grandchildren, and go on for several generations.
Of course, yes.
That's what we have to talk about. And so when you combine that with the fact that we saw from the arithmetic and the chessboard and so on, steady growth cannot continue for such long periods of time. Therefore, the first law of sustainability follows from those two observations. The first law of sustainability is you cannot sustain population growth, you cannot sustain growth in the rates of consumption of resources, period. That is not debatable It's absolute, and it's a law of nature. So that's the first law of sustainability. Well, the world is full of experts who lecture, write books, try to influence people, do consulting for big companies and for cities and so on. All kinds of experts, people claiming they're experts on sustainability. Have you ever heard one of these experts tell you the first law of sustainability, which I just recited?
Mm-hmm.
And I have never heard of anyone saying this who claims to be an expert on sustainability. They all talk about more efficient cars and more efficient light bulbs and don't use so much water and so on and so on. And those are all good, but they will not guarantee sustainability. It's absolutely guaranteed you cannot have sustainability without stopping population growth.
And the idea that this is an urgent problem, the idea that it's something that needs to be dealt with immediately. If I look around me, and if the listener looks around them and kind of studies the world around them and their own impact on the world, they're going to be thinking, well, it can't be that urgent, because there's got to be time for us to gather ourselves and to gather our children, our children's children, and educate them. And to run contrary to that, you talk about microbes in a jar. Can you tell me a little bit about that idea and show me the point that illustrates?
Well, let's imagine that you had bacteria that doubled in number every minute. So this means they're growing steadily. The doubling time is 1 minute. Let's suppose you put one of these bacteria in a bottle at 11 a.m. and then observe later that the bottle is full at 12 noon. So there's our ordinary case of steady growth in a finite environment of one bottle, and the growth has a doubling time of 1 minute. So there are 3 questions to ask. The first question is, at what time was the bottle half full? And the answer is 1 minute before 12.
Yes.
Because they double in number every minute.
Yes.
Now
most people are going to, until you explain it, people are going to assume that it's halfway through the hour.
Well, yeah, a lot of times people say, well, it's 11:30 or something. That's the case for ordinary linear growth, but exponential growth is much faster than linear growth. And exponential growth is 5% per year or 3% per year. Growth rates like that, anything that has a fixed fraction increase in a fixed period of time, is steady growth. And so the second question is, suppose you were an average bacterium in that bottle, at what time would you first realize that you were running out of space?
And again, the problem is that in the closing minute, as you look around you, you still have half the available space unpopulated, so you don't feel under any threat.
Yeah, at 1 minute before 12, why, half the bottle is available, and the other half is occupied. And so you say, well, gee, we got a lot of space. Well, it's just 1 minute before 12. And the third question is, suppose that at 2 minutes before 12, some of the bacteria realize that they're running out of space, so they launch a great search for new bottles. And they search offshore and on the outer continental shelf, and the overthrust belt and in the Arctic, and they find 3 new bottles. Now that is a colossal discovery. That discovery is 3 times the amount of space they ever knew about before. They now have 4 bottles. Before the discovery, there was only 1. Now surely this will give them a sustainable society, won't it?
Well, unless you think about it very closely, you're going to think yes, because it must mean that it sets them up for another 4 hours.
Well, just look at the score. At 1 minute, at 12 noon, 1 bottle is filled, and there are 3 to go. At 12:01, 2 bottles are filled, and there are 2 to go. And at 12:02, all 4 are filled, and that's the end of the line.
And again,
you have 2 more minutes.
And again, the core thing, the core element of this situation, the core driving force is that exponential growth.
A steady growth, and that's the centerpiece of our entire economy.
And again, it comes out not just in population, it comes out in finance as well. The idea of that exponential growth and the idea of people persistently being in debt and money being created from nothing. It's the same central idea.
Yes. Yeah, it's the growth of populations lie behind it all, but then, lots of people aspire to having a higher standard of living, and this means that our resource consumption per person is increasing. So what we have is a problem of increasing number of people and increasing consumption of resources per person. And that means then if the population is growing 1% per year and per capita consumption is growing 2% a year, then we've got something like 3% a year increase in rates of consumption of resources, and things are going to run out.
It's common sense. Speaking about population, China is famous for having put into place measures to curb population growth. I want you to talk about that for a moment, and also which country in the world, in the developed world, is the worst with regard to population growth, the population explosion?
Well, China put in a very coercive one-child per family policy something like 30 years ago. The official statement of justification that they gave at that time was that population growth interferes with economic development. Now, they have proven this is true. They've cut their population growth in half, and this has enabled them to put resources into the development of better lives for their people. They've spent it on developing manufacturing concern, and they are now sort of a world leader in terms of manufacturing, and they have incredible wealth because they've been exporting all of their manufactured products all over the world. And so they've had enormous economic growth made possible largely by cutting their population growth in half.
That is a very, very visible, high visibility example of the benefits. Yes, of course, yeah. But yet, China is the exception rather than the rule.
Well, I think if you go to any African country where there tends to be very high growth rates of population, they're all in poverty. They can't get out of poverty because the population is growing and the demands of new people for resources means that there aren't any resources that can be spared for giving better standard of living to the existing people. And you contrast this with Europe. Most of Europe is at zero or negative population growth, and it hasn't been the end of the world. It does present some problems, and in particular, the problem of Social Security for old age people is made very serious by stopping the population growth. But it's no answer, and you occasionally hear politicians or economists talking about this. We've got to have, our population is declining, we've got to get back into production in order to have people, young people, working to provide retirement for us old people. Well, that is a very real problem. On the other hand, it's no solution because it leads to bigger populations ultimately. The next generation that needs help will be bigger than the present generation.
So it continues to grow and continues to spiral.
Yes.
Sorry?
It's a real problem.
The United States, where does it stand on the chart with regard to population growth? Is it the worst offender? Is it mid-range?
We have the highest population growth among the industrialized nations. Ours is something like 1% per year, and most of the industrial nations of Western Europe are at zero or negative population growth, and the only countries in the world that have higher population are some of the underdeveloped countries. Now, in a lot of countries in Asia, and in some countries in Africa, there have been big drops in the fertility rates, the number of children per woman in the woman's lifetime, and this is very encouraging. This is movement in the right direction, but it hasn't yet been enough to appreciably slow down the growth rate of world population.
Is that an example of nature stepping in? The very fact that the fertility rate is dropping, is it almost as if, instinctively the planet is course correcting? I know it's happening at a too slow rate yet to make an impact, but is it possible that that's something that is happening there?
Well, it's natural in a sense. There have been lots of non-governmental organizations that have worked hard to prepare family planning and make it available in some of the underdeveloped countries. That's had a very helpful effect. Programs of educating women in these underdeveloped countries have helped enormously because educated women do not have as many children as uneducated women. And so there are a number of factors at work, all of which are important. I'm aware of a group that operates out of New Hampshire that goes to underdeveloped nations, and they produce soap operas for television in those countries, and the soap operas have family planning as part of the storyline. And this group, it's a non-governmental organization, it's called Population Media Center, and they have gone into countries, produced these television dramas which are shown in the countries, and they have family planning in the storyline, and they've been able to demonstrate significant drops in the population growth rate as a result of showing those dramas on television.
It's amazing. Again, it's amazing how you can educate people and the methods you can use to get messages across. Very, very interesting. Tell me about Julian Simon and the work and his belief, what he believed, because it ran contrary to the idea that population growth is bad.
Well, Julian Simon, who died a few years ago, was a professor of economics and business administration at the University of Illinois and was later in the same capacity at the University of Maryland. He just believed that we could have growth forever. And he wrote a book, and the book was published by the Princeton University Press. It's the most tragic book I've ever seen, because he says all kinds of things like we can just go on growing forever, and he cites, selected bits of evidence that seem to him to support his view. But you look at the facts and you find that he's just way off base. And later, toward the end of his life, he wrote a piece in the newsletter of the Cato Institute, which is a think tank in Washington, D.C. And here he said in this piece that we have enough knowledge and resources that we can continue to grow for 7 billion years. Now that is just, sort of beyond the pale. And two friends of mine in Washington, each independently sent me a copy of that clipping. One of them wrote, he said, I could call Julian there in New York and said, is that 7 billion correct? And got the reply, no, it should be 7 million. There's a big difference between 7.
Yes. Very big.
And my friend then asked me, well, what would the world population be if it continued to grow from the present size at just 1% per year, a tiny growth rate, for 7 million years. That's a nice problem in arithmetic. You can't do it straight out on a handheld calculator because it'll overflow. And so you have to know a way of sort of doing the calculation in a slightly different way. Well, if you calculate it out, it comes out in 7 million years at our 1% growth, that the population would be something like 10 raised to the power 30,000. And I had no idea how big this number would be. So I said to myself, well, what's the estimate that cosmologists use for the number of atoms in the known universe? And one of the estimates, I don't know how correct this is, about 1 atom per cubic centimeter on the average over the entire universe. Well, you imagine the universe is a sphere of 20 billion light years radius. Calculate the number of cubic centimeters there and put 1 atom in each, and you have the total atoms in the known universe is something like 10 raised to the power 85. Well, that's a whole lot less than 10 raised to the power 30,000. And so
it just doesn't. It just doesn't work. It doesn't
Julian's
fit.
Arguments were just so off base, so completely contrary to facts, and so easy to disprove by a simple arithmetic that it's amazing that he had all the influence he did. Because people in the White House, people in the Congress listened to him. He was a valued, trusted policy advisor, and yet he gave these stupid answers. And I once ran into now the late Jack Kemp, who you remember was vice presidential candidate with Bob Dole a few years back. And Kemp, I ran into him in the airport in Denver, and I'd never met him before, but I saw him, introduced myself, sat down, let's talk. I gave him a copy of a scientific paper I'd written on sustainability. And by that time, I was trying to board the plane, and he got in the first class, and I got back in the regular section. And when we got off in Dulles Airport in Washington and rode the transporter into the terminal, there he was sitting in a seat. There was a vacant seat beside him. So I went and sat down, and he'd read the paper, and I had in the paper a crazy quote from him, and he was kind of upset that I had used this crazy quote, and I said to him, I said, well, you sound just like Julian Simon. Oh, yes, of course, he said, Julian Simon, he's great. He's really wonderful. Have you ever met him? No, I have never met him. And but he clearly worshipped Julian Simon. By that time, we were at the terminal, and Jack Kemp went his way, and I went my way. But Julian Simon is still held in very high regard by the editorial board at the Wall Street Journal.
Well, you could put forward the theory that because the world of politics is so tied up in the corporate world, money is the king of all of those people, the idea of anybody saying that growth is good equates with money is good, and the idea of larger populations equates with more customers and more purchasing. So in some way you could put forward the argument that these people are blinded by just human greed and are not looking at the facts, the figures, the data, but are just thinking of the figures in their back pocket.
Well, yeah, they don't look at the facts, and they take the word of the economists. And the economists keep saying you've got to have growth and so on in order to have a healthy society, and the economists say this so often, and the politicians pick it up and repeat it, and in this presidential campaign it's being repeated. We've got to get back on the growth curve and get back to growing again. That nobody questions it, and yet it's obvious that growth is going to have to stop.
It's always, I mean, reading through your work, reading through your papers and your articles, to me, to bring it back to my own terms, it was like having a house party and starting off with 5 people and telling everybody, invite 2 friends,
Yes.
and tell them to invite 2 friends. And after a while, you're going to, around probably 1 a.m. or 2 a.m., you're going to have to put your hand up and say, stop inviting people to this party. We don't
Yes,
have
yes.
we don't have room. There's not enough beer for the party. You just have to
That's
stop.
right. Absolutely right.
We're going to take a short break on the Irish side of the moon, and stay with us. We'll come back and we will be talking with Professor Albert Bartlett. Okay, we shall return to the interview in just a moment. In the meantime, I'm going to read an excerpt from another paper by Professor Al Bartlett. Again, there's many passages from many of these papers that really leaped out and captured my imagination. This particular piece I put on the Facebook page for Irish Side of the Moon because I really liked it. So I'm going to start it off here. A Cautionary Tale, again is the title, and again another paper by Professor Bartlett. Just lining up here things on the screen so I can see what I'm doing. Okay. In a recent meeting, an architect went to the whiteboard intending to draw some explanatory diagrams. He had designed the building and had specified a whiteboard instead of a conventional chalkboard in the room where the meeting was held. He picked up a pen from the tray, took off the cap and tried to write. The pen was dry. He picked up another pen and had the same experience. There were about half a dozen pens in the tray, and he quickly found that every one had expired. Someone in the group went to an office and brought back several more pens. These worked, but they did not seem to be writing at full strength. A member of the audience spoke up and said that there were important lessons in this experience and that he hoped that everyone had learned all the lessons. Number 1. Has anyone ever seen a piece of chalk that would not write? Number 2. Every piece of chalk by its size tells at a glance how much more writing the piece can do. 3. A whiteboard pen costs much more, perhaps as much as an order of magnitude more, than does a piece of chalk. And I'm just going to skip the next few paragraphs of text and continue to go back to the numbers. 4. The shelf life of chalk in office storage before use is probably infinite. Because they contain volatile solvents, the shelf life of the felt pens is probably much shorter. 5. One can guess that 80% of a piece of chalk winds up as lines on a chalkboard, but that only a few percent of the coloured dye in a pen gets on a writing surface before the solvent is all evaporated and the pen is then dead. 6. It will be interesting to know, in average use, how many total meters of line are actually drawn by one of the felt pens before it expires, compared to the total meters drawn with the average piece of chalk. It would not be surprising if, in average use, the meters drawn by the piece of chalk was at least an order of magnitude greater than the meters drawn by a felt pen. 7. Put these together and the dollar cost per meter of line drawn on the board may be as much as 2 orders of magnitude higher, a factor of 100, for pens on whiteboard than it is for chalk on chalkboard. 8. And what about the environmental effects? When you are finished, the little nubs of unused chalk that are discarded are only small volume of waste that is probably benign when thrown in landfills. The felt pens, with their aluminium or plastic bodies, add up to a much larger volume of waste. They may still have small amounts of remaining solvents, which is a pollutant. Throwing away aluminium or plastic rather than recycling them is unconscionable. I love that piece. It goes on, but those are the 8 key points. I just wanted to share it, so as I turned that into a picture, I put it on the website. Have to say, hands up in shame, in my office I have whiteboard and markers, not chalkboard. Gotta be honest, didn't think about these things until I read the piece. And I'm on the line with Professor Albert Bartlett. We've been talking about math and the idea how it can inform us about the world around us, and you have used some fantastic illustrations and graphic and scary illustrations about population growth and its impact on this world of ours, which is not limitless and does not have infinite resources. Let's bring it back down very, very close, just down to a very concrete example. One of the papers that I have that you wrote, A Cautionary Tale, looking at the idea of an architect writing on a whiteboard and finding that his marker doesn't work. And from that one incident, you extrapolate 6 or 7, 8 points that are well worth dwelling on, and certainly I think there's a lot to be learned from them. Talk to me a little bit about your cautionary tale about the architect and the marker on their whiteboard.
Well, whiteboards are sort of replacing chalkboards in schools, universities, colleges throughout the country. And I think we have to look at these things and see that they are very, very bad. Now, the thing that tipped me off to this, I was at a meeting and an architect was speaking, and there was the whiteboard that he had specified for that room. He picked up a felt pen from the tray of the board, tried to write with it, and it was dead. Picked up another one, it was dead. All of them there that he picked up were dead. Somebody had to go down to the office downstairs and bring up a new box of pens before he got one that would write. Now, if you look at a pen, you have no idea how much longer it'll write. And the usual condition of the pens is that they are empty, that they've dried up, that they will no longer write. Now, compare that with a piece of chalk. You can look at a piece of chalk and tell pretty much how much longer you can write with that piece of chalk. The size of the piece tells you how much longer you can write with it.
Of course, yes, exactly, and it's a brilliant point. It's so obvious, but I never thought about it till I read your words, and I thought, yes, it really is just common sense.
And a piece of chalk costs you, maybe 10 cents, and one of those felt pens costs you $1. And if you look at it for large classrooms, the felt pens don't leave a very wide mark, and so the writing with them may not be visible, legible at a large distance as you sometimes have in like 60, 70 feet in a lecture hall. And so chalk, you can get very soft chalk. The soft chalk is sometimes called railroad crayon, and we found where you could get it, and so we buy this by the case. And it's a very soft chalk, but when you write with it, it leaves a very wide line, so it's quite legible. Now, if you take these felt pens, some of them, not all of them, but some of them, the solvent in them is very obnoxious. And it smells like ether, some of them, to me. I don't know the smells very well, but it can't be healthful for a person at the board to have an uncovered pen emitting these toxic fumes all the time and writing. And some of them apparently have water, and I can't smell any solvent that's carrying them. And I think these ones with the noxious solvents should be outlawed. And in particular, I know that these felt pens, these writing pens, seem to have replaced crayons for young children who have coloring books, and they want to color things in a book. And I remember once just seeing on television a group of young children, 2 or 3 years old, who were coloring in their coloring books, and they, as children often do, they had their faces down very close to the pens as they carefully filled in the colors in the outlines that were in their coloring book. And so their faces being down close there, if those pens were emitting these toxic fumes that some of the pens do, then I hate to think what it's doing to those children.
Yeah. what does it say about us that we select these things? I mean, we go from something that, and you make this point, we go from something that has been around for generations and is proven to something that is maybe a bit sexier, but is much more expensive, much more resource wasteful, and can also create problems in terms of suddenly you can't find a marker and there isn't one in the shop, and because of that you can't do what you intended to do. Why do we get drawn into those situations of ignoring something that is working?
I don't know. You know, the whole society is sort of hooked on improvements. And we've been duped into believing that any change is an improvement. And lots of changes are not improvements. And often the changes present very many new problems of their own. And I think this case of the pens replacing chalk, that's a case in point. That the new pens present many problems, and not only in their use, but in their disposal. A piece of chalk, you can just throw it away because chalk isn't much different than the earth that we walk on every day. But those pens, well, some of them are aluminum, some of them are plastic, but you've got to recycle them, and you've got to send them out and it costs you money to recycle the things. And so on every turn, it's more expensive. And a lot of people think if things are more expensive, they're better, and they just don't stop and think about the negative effects of some of these changes. And of course, it's the automobile industry that's sort of been doing this for decades. They have model changes every year, and their advertising people have to scratch their heads to try to figure out how to present a changed shape of a fender and sell that as an improvement, when actually it's trivial.
Yes, and yet they convince the masses that it is. Oh my goodness,
that it's an improvement. Yeah,
and they convince people. You mentioned problems there. You've said as well the chief cause of problems is solutions, and this is one of the phrases that comes up. What do you mean by that? Is this an example of that when you say the chief cause of problems is solutions?
That is Eric Severide's law. Eric Severide was a national journalist, and he observed that the chief source of problems is solutions. Now let's just take the case that we're running out of oil. That's the problem. So they find a new way of drilling and getting oil out of the ground. It's called hydraulic fracturing, sometimes shortened and just called fracking.
Yep.
Now, that presents all kinds of new problems. When they are working out near a city or a town or a subdivision or something, what is alleged to be lots of release of toxic gases that can hurt people, and the fracturing requires enormous quantities of water, several million gallons of water for every well that's fractured. And when that water is mixed with toxic chemicals and sand when they put it down in the well, and then they have to pump it out before they can start pumping out oil. And when they pump it out, they got to put this mess somewhere, and so they got to dispose of it. And so all these problems of gases being released that are toxic, all these problems of what do you do with the water afterwards, and then there are problems if you high-pressure fracture things, there's a small chance that you can trigger small earthquakes, and that's happened in some cases. And so these are all problems that are caused by the hydraulic fracturing, which was a solution to the problem of getting more oil.
And then you have nuclear power, nuclear fission, nuclear fusion, often trumpeted as the way forward, and yet with that there is also the negative. There are also other problems.
That's very true, and that's a good case, another example of Eric Severide's law. You find a solution to something, and the solution presents you with more problems.
So what does the listener do? What can the person listening to this conversation, the man in the street, Going back to the very beginning of our conversation, as we come in now towards the end of our conversation, you said yourself that when you were younger, you were in a situation where you thought, oh, perhaps this is going to run out, but the people in power they know what they're doing. It's not up to me to be thinking about those things. Let's bring it right forward to today. Somebody listening to us right now might also have the idea that, well, these are big concerns, population growth. It's too big for me. I can't impact on it. What would you say to that person right now in order to get them to do something?
I would say fight population growth in your community whenever you can. And what we have is communities across the country and states across the country who spend big advertising budgets trying to get more people to come to their state or come to their community. And this is insane. If you got a big factory coming to your community, yes, it'll raise your tax revenue. But at the same time, it raises much more the demands for expenditures from those tax revenues. And we can say it's absolutely true at every level throughout the United States that population growth or community growth does not pay its way. Taxes at the municipal level have to go up to pay the cost of growth, and that's true from coast to coast. Now, I've debated this with developers who make their money by building new houses and so on. And they when I go over the facts with them, they admit that yes, we have taxes have to go up to pay the cost of our new development. But then one of them just said to me, "What we've got to have growth," as though no growth was totally unacceptable. What we need is stability. And it's interesting, the condition of no growth is not called in the public press, is not called a condition of stability. It is called, what is the word they use? Stagnation.
Oh, okay.
So if something is not growing, it's stagnant. Well, that's kind of a nasty word. I'd much rather say it's stable. If it's not growing, it's stable, and that's a pleasant word.
Yes. And it's very true what you say, because it's how these things are packaged is very important. The packaging of one word versus another word, and the connotations that go with that word. And you're right. Stagnant implies death and decay, but stable does not.
Yes.
The idea of the person listening to us talk affecting change in their own community comes very much back to a gentleman we interviewed recently, Dave Gardner, of course, you know, who made his Growth Busters documentary. And a big part of his message as well is the idea of looking at the town you live in, and is the town able to sustain itself? And if not, then you have a responsibility as a citizen to step up and make sure your voice is heard with regard to putting a halt to that growth. And that's essentially what you're saying as well. Yeah. Rather than somebody focusing on the big picture, look on their own.
Look at your own community. That's where you're going to have some. And you know, another thing that's happening with the growth is it's destroying our democracy. And this is because, for instance, when I came to Boulder, Colorado, on the faculty of the university in 1950, the population of Boulder was 20,000 people, and there were 9 members of the city council. Today it's 100,000, and there are 9 members of the city council. The population is 5 times as big as it was when I came here, and that means then that in those 62 years, democracy in Boulder has declined to only about 1/5 of what it was in the year 1950.
That's a brilliant observation. Brilliant observation. Great, because again, it's impossible to argue with facts and figures. It's impossible to argue with data like that.
And you can see the same thing in the United States Congress. From 1990 to 2000, the U.S. population grew approximately 13.1%. But the number of members of the House of Representatives did not change. It's 435 members. So this means then that in that 10 years, every congressional district had to be redrawn so that it had 13.1% more constituents in it than it had had in 1990. So you can say right away, democracy at the national level declined 13.1% in just 10 years.
Wow. Brilliant. Okay. Again, fantastic way of looking at the figures and a great way to make a point. In the closing minutes, I always say this to everybody that we talk to on the Irish Side of the Moon. I always like to step away from the message for a moment and ask the person how they do what they do. And particularly with regard to messages like yours that are not popular, it's un-PC, as you've said yourself. It's not the mainstream message that government wants to put out there. Yet, you do not waver in your belief in the message, and you continue to bring that message out at every opportunity. How do you do that, and how would you tell somebody who has their own message, whether it's the same or a different one, but something they can see the importance and the urgency of it, and they need to get it out, but they may not have overwhelming support? What would you say to them about how you do it to make it understandable so that we can all do what you do?
Well, I do a lot of writing of letters to the editor.
Okay.
And the local papers and some of the time to the Denver papers. And these letters to the editor, I'm now quite well known around, certainly around Boulder for my letters. I have people, just yesterday somebody stopped me on the street and thanked me for all my letters, so the people read them. And but you know, things haven't changed very much in Boulder. We're still have a city council that's approving new subdivisions and is approving new apartment buildings, and they seem to think that the growth can go on forever.
Are you pessimistic about the future?
Yeah.
Do you think? Okay.
Yeah. I don't see signs that people will recognize the facts until it's very, very late. And of course, at the biggest level, people aren't doing anything serious about global warming.
Oh yeah, I mean it's not. Yeah, exactly.
Global warming is the biggest threat to the existence of humans on the Earth, and yet you have people in Congress who say it's all a fake and don't believe it, and other people saying, "Oh well, we can adjust to it." Well, we had a day here recently out in western Kansas where the temperature was 116 degrees Fahrenheit, killed all the grass. The farmers are having to send their cattle to market early because there's no food to feed them. And so some of these people in the Congress and elsewhere who don't believe in global warming or believe we can adapt to it, they ought to go out to that Kansas community and say, well, now you people start adapting.
When you look at the next few decades, do you think that back in 1972, when limits to growth predicted the fall of society, as it were, in the middle of this century, do you think that everything we've done since 1972 has brought us closer and closer to making that prediction a reality? Yeah, there's no room. And again, your resolve, I would say, comes from the fact that as your foundation, you've got math and figures and common sense, and these are things that are very difficult, nigh on impossible, to argue with once the reader
1972, they plotted graphs of these 5 parameters that sort of describe the world economy, and so they've redone the study as recently as 2002, and I think they're redoing it again now. And in 2002, what they found was that in the 30 years since 1972, everything has followed the 1972 predictions pretty closely.
So again, we have every reason to believe they're right, simply because in the decade since, in the 4 decades since, they've, as you say, got things right pretty closely.
Yeah.
In terms of anything optimistic about the future before we part company, do you think education, is there a hope that maybe we can educate the next generation coming? Is there any hope? I know we need to get the people at the top now to implement those changes, but even could the next generation, with the right tools and the right resolve, could they do a lot to
They can do a lot more than we've been able to do. And, the advice I give, I still lecture on this, and the advice I give to students is you cannot let other people do your thinking for you. And so we've got these 2 presidential candidates shouting at each other, and everyone in Washington wants to do our thinking for us. We've got to think for ourselves and tell them what we think.
Very true. Very wise. For people who are listening to you now who are not familiar with your work, they can go to your website. What's your website where people can read your work, read your papers, even purchase a book which collects your papers and your writings? What's the website address?
It's albartlett.org. The Al Bartlett's one word, ALBARTLETT. And you can go on YouTube and you can see the lecture, and it's called Arithmetic, Population, and Energy. And it's a 1-hour lecture, and I've been giving this lecture since 1969.
And I would encourage everybody. I think it's a fantastic argument. You first came to our attention in Growthbusters. Fantastic collection of writing. I've gone through your papers over the last 2 weeks. Again, directing people there, directing people to YouTube. These are urgent issues, urgent problems, and it's great. As I say, in spite of the fact that it's not a popular message, you do.
Oh, that Growthbusters video is very good. I know that I'm in it, and I know the guy down in Colorado Springs who put it together. It's very good.
Very, very good. I watched that about a month ago. I spoke to him. It's very, very good. There's so much material in that movie, and so many people like yourself that have such important messages to get across. It's well worth watching. So that's also, again, we're directing people from our website and from our shows to Dave and his work. But also, as I say, today we're directing people to your work and to your message, and hoping people will learn quickly from what you have to say, because there isn't much time left, really, when you think about it, which is...
Thank you very much.
It's a pleasure. Professor Bartlett, a real pleasure to speak to you today. I'm glad we thank you for making time for us, and we hopefully we'll talk again, and maybe in another conversation things might be more positive. We might have good things to say. Thank you for your time, and thank you for your work as well.
Thank you.
That brings us to the end of another Irish Side of the Moon. This is Michael Leddy at the microphone. That was Professor Albert Bartlett, and first came to our attention in the Growthbusters documentary a few weeks back. Dave Gardner, check out irishsideofthemoon.ie to hear our interview with him, to hear about that movie. Go to the Growthbusters site. But yeah, Professor Bartlett's work and his common sense and his logic came to our attention because he was in that movie, so we investigated him and reached out to him. Shane reached out to him, and delighted to get him on the show. Very, very pleased to speak with him. This is an issue which is really capturing my personal imagination. If you heard the Dave Gardner show, you know what I mean. It's really striking a chord with me for whatever reason. Very interested in pursuing this message, adding this message to the core messages of Irish Side of the Moon. So don't be surprised if this crops up again, and I'm interested in taking that movie and showing it locally and stuff. So if I do that, I'll make it known to you listeners. Thank you, as always, for making the time, taking the time to listen to the show, and please reach out, check us out. Best way to get to us is on Facebook. Best way, it's something that's checked every day. We're on Twitter as well. You can email michael@theirishsideofthemoon.ie, and you're very welcome to do so. Thank you.
We are Irish Side of the Moon. Freedom of information, personal empowerment. The Irish Side of the Moon.
I still have a dream.
This is just a ride. We can change it anytime we want. It's only a choice. No effort, no work, no job, no savings of money. A choice right now between fear and love.
Freedom of information, personal empowerment. The Irish Side of the Moon.